chapter 7b. We are going to be covering equivalent equations, okay? So, very important on what you need to do. So, let's just get to it. All right, so the whole point of this is to be able to solve equations algebraically, keyword algebraically, not by inspection. Last lesson in chapter 7a, I taught you all how to solve by inspection. I don't want you to do that. I'd say save this to check your answers. Okay. But the whole point is to solve algebraically. Now, so what are they first thing? Okay. You gotta think of it like a balance scale. It's like you got something here, you got something here, you got some piece of equipment holding each of them up, and it needs to stay the same. Okay. Now, this might be a whole lot of confusion right now, but this will make a whole bunch of sense later on. Um, what you need to do is you just need to be able to add or subtract, multiply or divide, and then swapping the left side with the right side. But this will make a whole bunch of sense as soon as I go inside the examples, okay? So don't worry about this section too much. This is just like general. Now, when solving for the variable, get the variable by itself. And to do that, you apply a series of operations. We're doing what we call inverse operations. So f- just a recap, okay? So you have operation and then you have the inverse of it. So if I have a plus sign, okay, the inverse is a minus, vice versa. If I have a times, the inverse is divide, and vice versa, okay? So that's what we do. Now, I have a couple examples here, so let's just get to it. So I have x minus 4 equals 16. So if you just remember, we're trying to isolate the variable. In this case, my variable is on the left-hand side of the equation. So I'm going to keep it there, leave the x there. Now, have a look at the rest. Have a look at the rest of the left-hand side. Do I have anything that's in excess? Like, is there anything that I don't want to stay on the left-hand side? In this case, we have the minus 4. This minus 4 we want to get rid of. Now, to do that, we are going to apply the inverse operation of minus 4. So let's just go backwards here. What's the inverse operation of a minus? It is a plus sign. What you are supposed to do now is to apply this plus 4. I'll just say plus 4 to both sides of the equation. Okay? So if I write it out properly, it would somehow end up looking like this. X minus 4 plus 4 equals 16 plus 4. Now, I typically don't want to write this out every single time, but I'll write it down just because we're in the beginning stages. I just want you to get comfortable with the idea that when we apply the inverse operation, it just happens to both sides, okay? Now let's have a look. I have x minus 4 plus 4. Well, what's negative 4 plus 4? That just turns into 0, no? So I end up with something like x minus 0 on the left hand side. And then I have 16 plus 4 from the right hand side, and that equals to 20. Now, obviously, when you subtract by 0, nothing changes, so it just ends up being x equals to 20. What you can do is check afterwards. So you check if your solution, this is now called your solution, by the way. This is called your solution. So this is after you've solved for everything, you've solved for the variable. You found that this number here is what the variable represents. So what you're going to do is substitute. So when you substitute x equals 20 in, let's just check it out. 20 minus 4 equals 16. 16 equals 16. So it's true. So that's what we want. Okay. So that means x equals 20 is the correct answer. That's what we want. Now, I'm just going to make some space here. So let's look at the second example. I have negative 2u plus 7 equals 17. So let's just apply the same kind of logic, okay? So have this plus 7 here. So I want to get rid of it. And we are now going to apply the operation of minus 7 instead, because the inverse operation of plus is a minus. Now, while that's happening, that means if I were to write it out fully, it would be negative 2u plus 7 minus 7 equals 17 minus 7, and that just does the same thing. Once you apply the inverse operation for what you want to get rid of, it technically automatically goes to 0, and you just write whatever's left over depending on the side of the equation that you're on, okay? So my left-hand side will now just equal to negative 2u, and 17 minus 7 is just 10. Now, I'm just going to highlight my u again. I might as well just keep highlighting u because that's what I want to keep. So I want the letter u by itself. I have this negative 2 attached to it. I need to get rid of this now. Get rid of. How do you reckon I'm going to do that? Well, if you remember from last chapter in algebra, negative 2u is the same thing as negative 2 times u. We are just going to apply the inverse operation of this. So the inverse operation of this is in fact, I'm just going to write it out again. It's actually divide by negative 2. So once you apply that step of dividing by negative 2, this is what technically happens. So I'm going to divide both sides by negative 2. When that happens, 2 divided by 2 is 1. When you divide a negative by a negative, it just becomes a positive, okay? So it becomes a plus now. And then I have 10 divided by 2, which is 5. And when you divide a positive with a negative, I just end up with a negative right there. So your final answer is actually just u equals to negative 5. Okay. Now, I've run out of room to do the checking, but you could probably do that in your own time. Okay. So I'm going to give you some time to try and figure this out. Um, maybe try and spend a couple minutes, ideally less than 5 minutes just to get this done. Um, you can just pause the video here, and then I'll have my solutions when we come back. So here are my solutions. So everything's all here. I'll upload it on the PowerPoint slide. I'll upload it on Google Classroom. Okay. Yeah. So these are the questions that I want you all to do. Please make sure you do it. We'll move on to chapter 7C. Okay. Take care.